Now we are going to introduce the concept of crystal systems. There are three ways in which we can define this. The first one is one dimension space lattice, which is the simplest one. So in one dimension, the arrangement will be as shown in the diagram, wherein the atoms are placed linearly at a particular distance d. So now to describe this kind of arrangement, we need only one parameter, and which is the distance between the two successive atoms. The second type of arrangement is two-dimensional space lattice. Now to describe any system which has two-dimensional arrangement, we need three parameters: the two sides and the angle between them. So we call this particular angle gamma by convention, and the two sides are called A and B. There are five arrangements possible in case of two dimension. The first one is the square unit cell, in which both the sides are equal, so A will be equal to B, and the angle between the sides is 90 degrees, so gamma will be equal to 90 degrees. The second one is called rectangle system, in which the sides will be unequal, so A will not be equal to B, and gamma will be still 90 degrees, so this particular angle between the sides is still 90 degrees. The third type of unit cell is called hexagonal unit cell, in which the sides are equal but the angle is 60 degrees. You can actually look at the arrangement. Why is it called hexagonal? It is because if you join 1, 2 and 3 unit cell, which I will just mark in terms of red color for simplicity. So this particular unit cell that I have marked in red color, along with this unit cell and along with this unit cell, will form a hexagonal kind of a pattern. So that is why it is called hexagonal unit cell. The fourth one is called rhombic unit cell, in which again the sides will be equal but the angle cannot be 90 or 60, because if the angle is 90, then it becomes square type of arrangement. If the angle is 60 degrees, then the arrangement becomes hexagonal arrangement. And the fifth arrangement that we are going to talk about is called parallelogram. In this case, A and B are not equal, and also the angle between them is not equal to 90 degrees. Because again, if the angle is 90 degrees, the arrangement will become rectangle triangle. Now let's talk about three-dimensional arrangements. Now to describe any three-dimensional system, we need 6 parameters: 3 sides ABC and 3 angles alpha, beta and gamma. Now by convention, angle between sides A and B is called gamma, angle between A and C is called beta, and angle between B and C is called alpha. There are 7 types of crystal structures that are possible in case of 3 dimension. So 7 primitive unit cells can be shown as per the diagram. The first one is called cubic, tetragonal, orthorhombic, monoclinic, hexagonal, rhombohedral and triclinic. Let me give you a table in which we will describe the relationship between the sides and angles for all these systems. So you don't actually have to draw these diagrams in IIT JEE exam at least. Now the three-dimensional arrangement can have 14 different types of combination of crystal structures. Those are called 14 Bravais lattice. I have tried to summarize all the possible systems in case of 3 dimension. So the first one is cubic system, in which all the sides are equal, A equal to B equal to C, and all the angles are 90 degrees. The examples are copper, ZNS and KCl. The type of unit cell mentioned over here corresponds to: S is your simple or primitive unit cell, BC is body centered, FC is face centered, and EC is end centered type of unit cell. So all of the systems will have primitive unit cell present, and additionally some of them may have other non-primitive systems also possible. So for example, tetragonal arrangement in which one of the sides is unequal, the angles are still 90 degrees, all of them, has two types of possible arrangement: simple or primitive and body centered. Only the orthorhombic arrangement has all four types of cells possible. You have to remember this particular table because sometimes the questions will come from this particular table. So for example, you may be asked which is the crystal system in which all the types of unit cells are present, or they may give you, let's say, what are the axial distance possible in case of rhombohedral system and what are the axial angles for that particular system, and you may be given four options and you will have to select the correct option. It will be better if you can remember the examples also, because sometimes they may ask you questions directly regarding these examples also. Now together, if you want to count, there are three systems in this case, two in this case, four in this case, two in this case, and one each in the last three systems. So in total there will be 3 plus 2 plus 4 plus 2 plus 3, 14 systems. So that is why it is called 14 Bravais lattice.